Anyway, welcome. I think with the amount of folks here, you could all just kind of fill up the first 2 rows and we should be good. How many of you who here have come here to learn? Right. Be inspired. Okay, well, wrong talk. Seriously, wrong talk. And I want to put this very disclaimer out right now so that you don't end up saying, I didn't learn anything. You're not. This isn't the place to learn. Fortunately for you, normally a talk like this, they put it as a keynote, so you've got no other choice, right? You're like, shit, I paid for this thing, I might as well go. Now you've got like 4 other talks you can go to if you want to learn something. Here, you're not going to learn. Here, you're just going to watch me rant. That's essentially it is. That's what it is. This talk is a rant. How many of you came to have ever seen my Silver Bullet Syndrome talk? Right. So if you've seen that, this is the sequel to that, right? It's a sequel to the Silver Bullet Syndrome talk, which you might be wondering, well, what was that talk about? Well, that was a talk about me ranting at the industry, and the industry just doesn't stop giving, right? It's just over and over again. So, but with many sequels, there's always a risk, right? That we've seen so many movies and things that were great in the first part and then totally crap in the second part, apart from TED 2. TED 2 was way better in part 2 than part 1, and my colleague actually put me next to TED at a TED talk, so I've accomplished that in my life as well. So I like to think of this as more of a director's cut, right? Because first, I take the pressure away of it being a sequel. Second, a lot of the jokes are the same. And third of all, you know, I'm basically saying the same thing, but from a different angle. One of the things that feedbacks I got with my first talk was, you know, it's extremely dark and demotivating. So a director's cut is kind of like a new ending, right? No, this one is still dark and demotivating. So I haven't improved in that part. But let's take a step back and ask ourselves why we're here. I also really appreciate the fact that someone thinks we're here to suffer, right? Everyone, essentially the whole world, thinks that we're here to suffer. But I'm not talking about life in general. I'm talking about tech. Like, what are our objectives in tech? So we're here to solve interesting problems. How many of you love solving interesting problems? Raise your hands. Yes, it was brilliant, right? It's absolutely brilliant. To make boatloads of money. Come on, be honest. Yeah, I mean, I'm from Spain. That concept doesn't exist, like make boatloads of money. So you don't go into tech in Spain to make boatloads of money. To automate everything, yes? Yes, I love that aspect of it. I mean, that's what made me fall in love with software development, that I understood that I could actually automate stuff and you know, make things so much easier and more efficient and actually end up helping people. Sometimes we've helped them a little bit too much, that we don't even need those people anymore, but nonetheless, it was a good need, right? And it's to solve needs. It's to try and help people. It's to solve problems that we have. And talking about needs, you know, the year was 1990. Anybody remember what happened in the year 1990? No? No, it was a time of good music? No. Tim Berners-Lee came out with a system to manage docs, right? He had a need to manage docs. He was working at CERN, and he came up with a protocol, a language, a browser, a web server, and a website, because none of that existed. And it was basically a nice system that he could manage docs and people could find their way through docs. It was born out of a need. Now, take 30 years forward and we end up with, you know, our system consists of a distributed set of microservices that talk to each other using GraphQL. Messages are stored in ActiveMQ, and using Kafka as a fail-safe option, we use serverless technology to calculate data which is stored in Redis. We're looking at adopting blockchain. And this is like your grocery store that has like 12 customers, but they need the scale, right? And you ask yourself, like, why? Why are you doing these things? What is the purpose? And I actually want to do this like new show, which is kind of like Gordon Ramsay going into tech and saying, well, why? Why are you combining this crap? And just as someone said to me, yeah, Gordon Ramsay didn't actually make any of those restaurants be successful. I don't care. It's not about the success. It's just about the anger, okay? So if you want to invest some money in me, please do. But back in the day, right, and I'm talking many, many years ago when I got into like my first kind of official job was working as an ISP. That was like, I don't know if anyone remembers Radius software where you had to like dial up and get connected, and we like had this frame relay that we would allow people through. And of course we started to do that, and then we started to create websites for people, and people would email us like descriptions of houses that they want to sell, right? I live in the south of Spain. We've got sun and property to sell, right? And so we would put these descriptions up and then update the pictures, and it started to become tedious. And my boss said to me, you know, like, stop doing this. We need to find a better way, right? Automate things, right? Not have to do this all manually. And we came up, well, we didn't come up. We started to use this thing called, does anyone know what that is? What is that? Come on, people, louder. Dark side of the moon, yes, but apparently it's also the logo for CGIs. I don't know why, but it is. CGI was a common gateway interface, and the idea was basically that you would have your web server call some executable, normally running Linux, and it would do something with it, namely, for instance, talking to a database, etc., and then combine that and send it back to the server. And we started to work with these things, and at my time, that was my claim to fame, right? I wrote a tutorial about ISAPI. ISAPI was the better version of it by Microsoft because it would allow you to not have to launch the executable each time, right? That was resource intensive. So the ISAPI was a DLL, so on the first request, it would launch, load the DLL into memory, and then subsequent requests wouldn't have to have that loading and unloading, and it was way more performant and better for memory. And Netscape did their NSAPI, and it was a wonderful world. It was like really, really simple, right? It was brilliant. You had a browser. Back then it was Internet Explorer. And you go to this computer, this process, and you would interact with this database, and it would spit out some HTML. It's just how things worked, right? Now they call it server-side rendering. Okay, but that's essentially what it was. And then someone said, you know what, this is really cool. Let's add some activity to it on the client side. And along came JavaScript. And JavaScript enabled us to do many, many things. Of course, nobody really understood JavaScript. Everyone understood jQuery. And we used to ask people, like, do you know JavaScript? They're like, no, I know jQuery. And it's fine. I don't need to understand JavaScript. Plus, how can you understand a language that was like, you know, developed in such a short period of time? So everyone started to doing jQuery, and it was really, really good. And things were kind of working well. But then people started to say, no, this whole refreshing the entire page is a really bad idea. It's not efficient. The customers need more. They need instant. Let's go for single-page applications. And then single-page applications gave us a ton of beauty, right? They brought us AngularJS, which allowed us to, in a very efficient way, after months, create a page. And then by the time we'd finished creating it, the new version came out, which was completely incompatible with the previous version. So you'd spend more time upgrading than actually creating the application. Some folks didn't like AngularJS. They came out with React. React was trying to simplify things. React was saying, look, the web is actually a very, very simple thing. Let's try and simplify it. And we came up with the architecture, which was this, which was called the Flux architecture, which was too hard for anyone to understand. And one person said, screw this. I'm going to make Reflux. I couldn't find a logo or anything. So that's the closest I got to that. But it started to go from the whole simple concept to something more and more complex each and every time. And this came along with its own kind of like patterns. Like Smalltalk came about with the whole MVC, right? You had the model, which was your data. You had the view, which was what you were seeing. And you had the controller that talked to the beast. Like, no, I'm not doing MVC because I'm doing desktop, therefore I'm doing MVP. What is MVP? Well, it's kind of like the controller, but it's not a controller, it's called a presenter. Okay, and that wasn't enough because Microsoft said, no, we don't like that, we like MVVM, right? What is MVVM? Well, it's kind of like presenter, but it's a little bit different, it's called the view model. But the view model sucked as well, so we're going to do it with MVI. What is I? It's intention. What is intention? It's what the user does. Isn't that kind of like what the controller does? Yes, but it's a subtle difference. But here is an entire blog post for you to understand that subtle difference. And now we've got frameworks embracing all of these things like Vue.js, and we start to see this whole single-page application kind of thing is starting to give us some issues in terms of performance, right? So maybe, just maybe, we could go back and do some stuff around the server. and render the information on the server, and you get beautiful blog posts that talk about how server-side rendering can boost performance and user experience. Like, wait, didn't we bring all of that SPA to improve user experience and boost performance? No, now let's go back to the server and call it server-side rendering. So we've gone full circle, and the best part about going full circle is that we don't seem to make, like, we're making the, you know how they say in your job, like, it's okay to make mistakes, but it's bad to kind of repeat the same mistakes? We're really good at that, right? We keep making the same mistakes over and over again. So, you know, essentially how we used to do it. So now I've got a website, which is a static website for a project I work on, which is called Ktor. And yeah, that's my website. It's 4 static pages, but it's really, really flexible, right? It's called Gatsby. Anyone use Gatsby? If you haven't, don't, right? This was 12 years of progress back in 12 years ago. Now it's even worse, okay? And if we look at what we're doing, we're basically creating data, we are reading data, we are updating data, and we're deleting it, right? That's what we're doing. We're doing CRUD. But it's shameful to say you're doing CRUD, because it's like you're saying you're just a simple person. Your applications are CRUD? Ugh, that's disgusting, right? The CRUD is very, very simple. You need to think about this more, right? But we were doing this CRUD, and what we did, we said, well, you know, we wrote some code to perform all these different actions. We wrote some code that would do a creation, we wrote some code that would do an update, and a deletion, et cetera, and we ended up repeating that code. So we said, well, you know what, instead of repeating that code, let's extract that code out and write some utility functions, which was great. We didn't have to repeat the code over and over again. But then we're like, well, we could use this in multiple applications, so instead of writing some utility functions, let's create a library, and then we could use this library across multiple applications. Right? But then someone said, no, there's a mismatch. You're doing it all wrong, because you've got, from one side, you've got this relational model, which is a SQL server. And in university and everywhere, they've told us to think about objects. And we need to think about objects. And our applications need to be about objects and not these disgusting relational models that are in the database. So what did we do? We wrote a framework, and we called that framework the Object Relational Mapper. And it didn't matter what type of database model we would use. We still wanted our ORM. I mean, you're using a document database, I still want my ORM. But there's no relation. It doesn't matter. I still want my ORM, right? And then this ORM starts to give us issues. Yeah. And then we're like, oh, well, this is performance problems. You know, I want to get all my invoices, and now my invoices is bringing all the lines, and I don't want all the lines because I only want my invoices, headers, and I only want to calculate the tops, etc. So they said that, well, you're designing things wrong, and thus came the big divide. Now, the big divide, if you've not heard of it, which I'm sure you have, is called command and query responsibility segregation. Now, back in the old days, that's why you'll see the reference in this blog, which is, did you mean cars? Does anyone know that reference? Right? When you used to Google CQRS, Google would say, did you mean cars? Because nobody knew what CQRS was back then. But it was basically taking the command and query separation principle and saying, well, just separate your reads from your writes. Kind of like what we were doing with our functions and our libraries in the reads and the writes before we brought all the object relational mapper in. But of course, when this happened, and when Greg Young, who's one of the folks that came up with this CQRS, when he was talking about it, he was talking about that and something called event sourcing, right? Which was basically the idea of, instead of just storing my data, I would be storing events and then play those events, which was fantastic, for example, in accounting software or things that you needed auditing, etc. But what did we understand as an industry is that, well, if we're doing CQRS, we have to do event sourcing as well. It didn't also help that the event store, which is the company Greg set up, was making a database for event storing, right? Event sourcing. So we started to combine CQRS, which was actually a very, very simple concept, which is just like have different ways to read your models and write your models and maybe separate them in a different way with event sourcing. And that wasn't really working out well. And then there was another book that came out, which was called Domain-Driven Design, which was 500 pages. And essentially everybody, the takeaway from Domain-Driven Design for the 90% of us was, oh, I have to implement this thing called the repository. right? The rest of it, screw that shit. No, I don't need any of that. I'll just focus on the repository pattern. And you're like, the repository pattern isn't really helping me. No, because you're lacking aggregate roots. What is an aggregate root? Oh, just create a class called aggregate root and make sure everything inherits from that. And away you go. And we came up with hexagonal and onion architectures and on all these different ways to kind of like put our applications together. And you're like, wait a second, what am I doing here? I'm just doing a CRUD. No, CRUD is too simplistic. You need to think about your ubiquitous language. You need to really embrace that domain. You really need to do, but my app doesn't require it. It doesn't matter. You need to do that. And we came out with tools that for some reason fit very well with domain-driven design, which I have no understanding of why Visual Studio fits in with domain-driven design, but apparently it was a great marketing tactic. And they said the architecture needs improving, right? Because the way that you're doing all of this is a little bit wrong, because essentially you're just creating this massive ball of mud, which is just one service, and you've got everything crammed in there, and it's absolutely bad, and that is completely wrong. And thus came what? Microservices, right? Which my friend Simon Brown says, you know, if you can't design a proper monolith, microservices aren't going to help you. Or in less subtle terms, if you've got a bowl of this, you're going to have a lot of this, right? Essentially, that's what you're going to end up with. And we were doing microservices, which most of them operate over HTTP. But of course, you couldn't just call your system an HTTP API. That was frowned upon, right? It's kind of like saying you're just doing CRUD, so everyone started to do REST. Of course, nobody read the REST part, right? They just meant REST is pretty URLs over JSON. That's essentially what it was, because REST was too hard, and you didn't, people that really weren't even doing REST were saying it was too hard, so that gave us 200 OK. Do you know what 200 OK is? It's called GraphQL, right? That's essentially it. We started to say, no, now let's take our ORM and we'll just map it over HTTP, and there you go. It's beautiful. And so now on my website, which is a static website, I have GraphQL to access my icons. It's beautiful. It's very, very flexible, though, I got to tell you. And it's adaptable. And of course, all of this requires building. And when we're talking about building, like, back in the old days, you take some source code, you put it through this thing called a compiler, it checks the language, checks everything is correct, and then it puts it through this thing that brings in the libraries, a linker, and you've got your little app. It's beautiful. It's self-contained. It's beautiful, right? Problem was you had to remember all of these command line arguments. And that was horrible. It was just disgusting. Like, I got to remember this over and over again. Now, we had these things called batch files or command files or script files, but it was kind of bad. And then, of course, there was make. Make was really nice because it basically allowed you to take C and C++ projects and put them together in a nice way and repeat that process over and over again. In the Java world, we got this thing called Maven. Anyone familiar with Maven? Right? We got this thing called Maven. In the .NET world, you got this thing called MS Build, which was kind of the similar idea. And, but someone said, ugh, that's horrible, because it's XML, right? XML is disgusting. It's absolutely horrible. I don't want to spend my life reading XML. And around the same time, this other thing was starting to make a come around, which was called Ruby, right? Anyone heard of Ruby? It's dead now, but it used to be alive back then, right? And there was this beautiful language called Ruby, and someone said, you know what? It would be really nice if I could use that same concept of this beautiful language to make my build files in the same way. And of course, they made this thing called rake. And in C# we got cake. In F#, they got fake. And yes, JavaScript did get Jake. But JavaScript also got grunt, gulp, and of course, now you got Webpack, which nobody understands. You've got to take a course to understand Webpack. Now, in the Java world, we also got Gradle, right? Gradle was like, well, we got Ruby, well, Groovy is a nice language, so let's try and kind of like replicate the same idea with Groovy because it's kind of nicer, and we got this thing called Gradle, and it was kind of good, right? Because you took all of this ugly, horrible XML, which was really, really long, and you substituted it for something very, very small, right? And okay, there was 3 files to it, big deal, but there were still small files, right? And the idea was that now you don't need to tell the build system how to do something. You just tell it what to do, and it'll figure it out. Of course, to do that, you need to figure out how to tell it what to do, which is like 200-page manual that nobody reads, right? So you end up on Google asking, like, how do I add dependency? How do I do this? How do I do that? In a very, very more approachable way to build systems. And if you've ever worked with Gradle or Maven, your biggest problem is always the cache, right? It just dies, right? So there's a top hit of like, how do I refresh cache in IntelliJ or whatever product, right? Fastest way to get into farming is just delete everything and just give up. That's essentially, like, this is the process that you go through with Gradle constantly until you just say, screw it, I'm done. But we adopted Gradle at JetBrains as well, right? We have this language. How many of you have heard of Kotlin? Right. So we have this language called Kotlin. And with Kotlin, one of the things we want to do is try and make it approachable to all platforms so that you can deploy it on any platform, whether it's Android, iOS, JVM, JavaScript, native, et cetera, So we said, well, we're going to kind of work with Gradle because the Android community also works with Gradle, and it's going to be wonderful. And what you can do is basically the idea is that you write Kotlin and you share code, right? So you save a lot of time. Instead of having to write the same code for multiple platforms, you save a lot of time by using Kotlin multi-platform. But of course, that time isn't time that we give back to you. That time isn't time that you can take away and say, I'm going to spend it doing my hobbies or play with my family. No, that time is the time that you spend now trying to configure Gradle for that shit to work. Okay, so we give something, but we take something at the same time, and that is configuration. And talking about configuration, XML sucks. We all know it, right? In fact, I was talking to a colleague of mine, a friend of mine that started a new job. And he was saying to me, he goes, everyone around me is young. I'm like, okay. He's like, they don't even know what XML is. Like, they've never encountered XML in their life. Okay, now XML, how many of you like XML? It's good. It's very explicit. It tells you exactly what it's doing, and it's good. But apparently, we don't like it. Why? Because it's too verbose. Because we have to write it. So we said, well, let's not use XML. Let's use something like JSON. And JSON is like, OK, yeah, that's less verbose, less, greater than, lower than. It's all wonderful. It's absolutely very good. But they said that, no, JSON isn't human readable. Because that's what I do in my life. I sit and I read configuration files as a book. I need it to be human readable all the time. It's not like I look up something with a search and replay. No, I need to humanly sit and read that, like a novel. And they said, no, this is no good. We need something better, which is called YAML, which I don't know why it's better, but it is. Because it uses white spaces, I don't know. It's a very long specification. Like, you can actually read through it and figure out why YAML is more human readable to configure stuff than JSON, if you manage to get to the end. But no, someone has said, no, YAML sucks. So they invented TOML. And I think Tom still uses it, right? And after you build and you configure this, now you need to deploy it. And deploy, you had a computer you used to deploy stuff on, right? You used to copy it. You used to X-copy it if you were on Windows. You used to FTP it. But then what would happen is that you're like, oh, I forgot a file, or I forgot some configuration parameter, all of this. This started to become a pain, and the whole works on my machine didn't work on my machine. And what did we do? We fixed that with Docker, right? We said, well, I'll just ship my machine, except we won't call it my machine, we'll call it a container. And the idea behind Docker is actually genius, right? Instead of having this VMware, I just have this little container that I could put all my stuff on, make sure it's part of my build process, make sure everything happens, and it works the way it should, right? Simple file. Now, of course, now you're in a world of microservices, so when you got to go a lot, right? And you got to deploy a lot of things, and you're like, well, Docker comes with Docker Compose, which allows me to put all of these things together, and it's really, really nice. But, that isn't enough for you. No, Docker Compose and maybe some script files and running that is not enough. No, you need the full-blown Kubernetes. You need Kubernetes to be able to deploy all of this. And Kubernetes, if you're not familiar with it, it's an open source system for automating deployment, scaling, and everything. And it's meant to simplify your life. okay? They tell you it is helpful for managing deployments, simplifying it. If you run into trouble, this is a real workflow, seriously. It's a real it's not a joke. It's a real workflow of how to debug Kubernetes, or as someone else was saying, like, this is Kubernetes, right? It's very, very simple at the top. And then, of course, you have to deploy all of these things somewhere. And again, back in the old days, we had an ISP. We used to put it on that server, and it was beautiful. And then along came Heroku at the same time as Ruby on Rails, which was fantastic because they really had an ingenious idea. They said, okay, well, you're pushing to GitHub, right? So instead of pushing to your main branch, back then it was called master, instead of pushing to your main branch, what you want to do is push to this other branch, and then what we'll do is we'll compile it and deploy it for you. Of course, most of it was Ruby, so they weren't really compiling, but they were deploying, and it was really, really good. It worked really, really well. And of course, some of the big names got wind of this, and they're like, oh, we can do the same thing, right? And then you got like Google Cloud products, right, which you can actually scroll through to see how many Google Cloud products there are, and whether you need any of these or not. But it's great. It's all there, right? And I'm not just picking here on, I'm not picking on anyone. I'm picking on everyone, even ourselves. But, you know, this isn't just about Google Cloud. Like, you get the same with Microsoft. Microsoft's also very pushing the idea of everything's going to be free. Everything's free until it's not free, right? Of course, once you get it all up and running, then maybe it won't be that free. I was going to create a video of AWS, but it took 1.5 hours, and I said, screw it. You can just scroll down through all of the services that they have here. There's like tons of pages. And you now, of course, this is good because it's all about the cloud, right? So you can take certification courses on learning the cloud. But before you do that, there are, and I'm not joking, there are certification courses that tell you what you need to learn. And then once you get that, then you go and learn that thing. Right? So we said to people, you know what? We're taking away you having to manage your own hardware and instead spend all of that time learning all of our services, which by the time you finish learning is no longer valid anyway because we call it for legacy projects. Right? Oh, are you using this service on Azure? No, that's for legacy. Use this other new one, which is much better. And then we call this cloud native, otherwise known as vendor lock-in. Right? Yeah, I'm using serverless cloud native. Yes, can you port that from AWS to Azure? Well, anyway, right? And of course, all of this you need to monitor and maintain. So let's talk about DevOps. DevOps was a very, very simple idea. DevOps was about developers and operations having insight into what each other is doing. It was about communication. It was about awareness. What did we do? We made it about tools, right? Like everything we do. We say, oh, DevOps? No, DevOps, we need Watchtower, we need this, we need that. And then we got with this 8 of DevOps, which we're up there as well. Nice. So we got all of these different things, right? Now you need a glossary of understanding what tools you need, or even if you need them, but it doesn't matter because you do need them. Why? Because the cloud providers are telling you you need them. And everyone else is telling you you need these tools. Right? But if you have issues with DevOps, do not worry because there's a scaled, agile, maturity framework, or short, SAD-MF. That can help you cope. Now, one thing I've left all in this out, right? We've talked about design, we've talked about building, configuring everything. One thing that I've left out in all of this is security, right? Because security is actually complex. Let's talk about it. And I'm not talking about security like authentication and authorization. That's relatively easy, right? That's like you kind of like do the best and hope it all goes well. I'm talking about this aspect of security, right? I'm talking about how we've actually built everything around us. You all remember this scenario, yeah? The person that pulled a little library from NPM. And again, I'm not picking on NPM because you have the same in all your ecosystems. That's, again, I said, you know, like we like to learn from our mistakes by making our mistakes again. So we take the mistakes that one ecosystem did and we say we're going to repeat it exactly the same. Same mistakes? Yep. But they had that? Yep, we'll have it as well. So this was a left pad, which was a very, very small service, and someone got pissed off or whatever. They decided to pull it, and the world broke. And this was it. That was the actual service. Community came together. Now you have left-pad.io, which is a service available 24/7, right? SLA. I was looking at this many, many years ago, and back in 2018, I found that there was a package which was 18 million downloads at the time and had 72 dependent packages on it, and it fits in a tweet. That was the actual package. ToString call R equals object array. And it was a function that's called isArray. And there's more. There's is negative, is positive, is zero negative, is zero positive, is array, is non-array, is false, is something like array. Has identity crisis. I'm pretty sure that one's already there as well. So that leads, going back to my little Gatsby website, this is where I am, right? Those are all the dependencies that Gatsby is pulling in, and I have no clue what they are. And I don't know if any of them are doing anything malicious or not. No clue whatsoever, right? I mean, it just goes on and on and on and on and on. And you've got to wonder for yourself, why? Oh, flexibility. Tomorrow, if I want to scale my 4-page application to 1 million pages, it's scalable. Shai's friend of mine's drinking game still stands. You can, and the beauty of this is that, you know, you think of a noun, Google it, if it exists, drink. But this, again, you can look for .jar, you can look for whatever .net is. It all exists in all the frameworks. Now, coming back to security, you would think, well, this isn't really an issue, except it is, and it's a recent issue, right? Malware constantly being found in small, tiny little packages that we're building upon. And this isn't just about packages. This is about Docker containers as well. 9 million Docker containers in the registry, right? How many of them verified? 10,000. Are you using verified images? Not always, right? Do you even know what those verified images are? Who are they verified by? So this is where we are. And the worst part is that when we build stuff, we don't even think about the versioning, you know? I mean, like, again, I'm old school. Back in my days, we used to check in everything in version control. So we would have reproducible builds. Now we just pull the latest version and hope for the best. We don't care if the latest version is compatible or not. We just put a star and make sure that it just builds. And if that latest version pulls in something malicious, who cares? But don't worry, procurement is on the job. At JetBrains, we get loads of questionnaires from people. Like, yeah, we're investigating supply chain attacks, right? And we want to make sure that the software you're providing is accurate because we heard about this thing called Log4j. Yes, you're using ReSharper. That's written in .NET. Log4j is for Java. Okay, so does that mean that it uses Log4j? No, it does not. Okay, thank you. That's it. That's what security has been reduced to. Procurement and a checklist. Right? And we continue to do all of this, and then we read articles about supply chain attacks and think, oh, well, yeah, well, it doesn't matter, yeah. But it's going to get better. It's going to get better because we've decided that all of this complexity isn't enough. Drowning ourselves in all of this isn't enough. We need to also drown the population in all of this, right? Because the cookie processing that takes 98% to complete and hangs around for 2 minutes isn't enough. Because all of these options that you have to go through to configure whether you want to visit a website isn't enough. All of that is not enough. Now we need to give the world Web 3, right? So yes, that's where we need to go now. Because now with things like, blockchain, we can have a more fair and distributed web. You know the web that computers are all over the world and different computers do different things in a distributed way? Well, we need to do that. But what we have isn't right because we need the blockchain, right? And then we'll end up with, yes, everyone owning content, which we all know is nonsense, right? And you talk about how we don't need to succumb to the corrupt governments and use things like Bitcoin to give us independence. And then you find out about how some of these biggest companies maybe are not that non-succumbent to governments, right? And you look at, like, this is, I still fail to understand this whole thing. Like, I have tried multiple times to understand NFTs and I cannot. Even when I understand what they are, I'm like, why? Why are we so stupid? Why are we so stupid as a society that we bought into this rubbish? Then I think about diamonds and I'm like, yeah, people bought into diamonds, right? the thing that's mostly available, you won't ever run out of diamonds, people think you do. I mean, how many of you know Bernie Madoff? Right? If you haven't, you don't know about Bernie Madoff. He's pulled off the biggest Ponzi scheme in history. Like, he's turning in his grave. He's like, I couldn't even fool people with this NFT shit. Right? If you haven't watched this movie, Wizard of Lies. So then you end up with the man who paid $2.9 million for an NFT of Jack Dorsey's first tweet loses almost $2.9 million. Well, I'm sorry, you're stupid. Like, sometimes you do have to say to people, you're stupid. It's okay. It is applicable. Yeah? And if you enjoy watching the absolute, you know, whatever it is that NFT and the Web3 is bringing you, follow this Twitter account. It shows you just exactly how wonderful it all is. Right? So, in summary, what is my point? Now, I don't really have a point, which is the point about what I said at the beginning, like, you're not going to learn much, you're not going to be inspired, nothing like that. I don't have a point. And this is one of the things that I always have around my talks. I don't have much of a point. It's especially, like, how can I make a point if I'm just angry and ranting at things? But there are some things to think about. Like, what are we doing? Going back to the question of what are we doing, why are we doing it? So we come, you know, we read these blogs, we come to these conferences, and we listen to thought leaders, and we think to ourselves, oh, well, I want that. Right? I need that. No, you want that. You don't need it. No, I need it. I need it because scale. And we forget about the context. I tweeted something yesterday. I said something around the lines of, you know, if you're implementing, if you only have a single implementation of an interface, don't use an interface until you need it. Look at that tweet. There is hate from all over the world. And like, what about this scenario? I said, I didn't say every freaking scenario in the world. I said this specific scenario in this context. No, you're wrong. No, someone else accused me of never programming, which is true. But anyway, that's irrelevant. But then we come to these conferences and we go to this talk and we're like, well, just because Netflix uses microservices and performs Chaos Monkey doesn't mean we need to. But it's so easy for us to forget this. And just because Uber switches from MySQL to Postgres doesn't mean we all need to. In fact, in 2013, Uber published a document about how they went from MySQL to Postgres, right? And they said they had issues with performance, whatever, and they needed to do this. And I remember exactly back then that folks were trying to do the same thing. They're like, well, if Uber is going to has run into this issue, I definitely am going to run into this issue. You don't have the same problem as Uber. Doesn't matter, I'm going to run into this issue. Plus, I really wanted to play with Postgres, so this is my great opportunity to do that. Right, 3 years later, Uber said how they went from Postgres to MySQL. You could have saved yourself time, money, and energy and waited 3 years and still be more productive. How we went from microservices to microservices and back again. Yes, because if you design a ball of mud badly, you're not going to, you're going to end up with multiple balls of mud that are badly. And you think, like, what is it that we're trying to accomplish? And all of this, of course, has another side effect. Because we listen to all these things, we read all these things, we come to these conferences. I mean, lately, I read conference titles, and I don't even understand the conference title anymore. It's like how to blah, blah, blah with blee, 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 and blue, blue, blue. Okay. And all of this, leads us to analysis paralysis, right? It's like, okay, so should I be using ActiveMQ or RabbitMQ? Should I be using DocumentDB or relational model? Should I be using microservices or monoliths? What pattern should I be using? What architecture do I need? And we spend up more time trying to investigate all of these things and think about all of these things, which oftentimes aren't even necessary. But when you go to a candy store, you're like, oh, I got all of these candies. Which ones do you need? I don't need any of them. But look at all these. Like yesterday, I was talking to Kevin, and he's like, we're talking about guitars, and he's like, yes, because I don't need a guitar. I'm like, of course you don't need. It's like, I don't necessarily need this. Of course you don't. Like, there are some things in life that you don't necessarily need. And then we end up focusing on the what as opposed to the why. It's like, what should I be doing? So then you start to wonder to yourself, why are we doing this thing? Is it CV-driven development, right? Because that's essentially what's ending up, right? Look at your CVs, look at my CVs, everyone's CVs. When you do a CV, what do you say? I managed to solve X, Y, Z problems or help X, Y, Z amount of people. No, you say, I know AngularJS, React.js, GraphQL, blah, 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 blah. And we write our CVs like this, and we hire people like this. Because we think that what? People have a limited capacity of learning, and we don't learn on the job, and we're going to be classified by the number of technologies that we know? No. And yet this is where we are. And we're like, no, but it's nice, it's knowledgeable. It's like it's driven by knowledge-driven development. And we're very, very fortunate. You imagine if civil engineers that are making bridges like, I've never done this kind of bridge, but I'm going to try it just in case. It may fail. And you know what? I'll do 5 just in case tomorrow there's more cars coming through. It'll be scalable, right? It's like we're really weird as an industry. Oh, well, it didn't work. I learned. And then we complain that our employers need to pay for our education. They're doing it every bloody day. Every time we open a new product and thing that we haven't used, we're learning on the job. But you don't ask yourself, do you really need that? Or more importantly, does my customer really need that? We don't. We hardly focus on that aspect. And we're just driven by this passion, by this love for trying to solve problems and engage with difficult things. And it's in our nature. I mean, that's what it is, right? As individuals, as developers, we're like that. And the industry is made up by developers. And it's encouraging us. It's giving us 600 services that we may never need, but they look really cool to play with. So let's maybe bring some of those into our application. But you don't need it. It doesn't matter. It's still very, very cool. And I'm not saying that there aren't complex systems in the world. Surely there are, right? But, this idea of we're building with flexibility in mind, sometimes we need to take this step back and think, are we actually making a system way more complex by doing this? When we talk about we're building for change, when we talk about we're building clean architectures, all of this comes at a cost. The majority of clean architectures, and clean is relative, right? Because your clean is my dirty, and my dirty is your filthy, right? But all of this comes at a cost. And all of this flexibility and abstractions and all of these things that we build in, often we don't end up using. Back to the ORM days. I was one that would build an abstraction over an ORM. How stupid is that? But I would do it. Why? Just in case one day I would have to swap my ORM out. Did I ever swap my ORM out? Never. But I would build these abstractions. And we do this on many, many things. And you're like, no, we're striving to build clean code. Yes, but at what cost? Right? How many times do we actually need that? But it's like we have this urge for complexity. And we want to solve complex problems with more complexity. And it's like, it's something like, well, it's a complex problem. And if you want to understand this, you have to really understand the complexity. Why? What, do we take pride in complexity? Why are we not trying to make things simple? Is it job security? Of course not. So we need to try and move back to simplicity. It's okay, it is absolutely okay to make things easier. It is okay to raise the level of abstraction. But if it's harder for me today to deploy an application using Kubernetes than learning 68,800 for the Motorola, that's not going in the right direction, is it? We've created an abstraction, but we made it very hard to understand. But of course, it's not an easy task. Because it's that balance of, okay, how can I make this abstractions? How can I make it simple? How can I solve problems? It's not easy. But it seems that we very often take the route of, well, it's just complex, so folks need to understand this complexity. So we need to strive to make things simpler. Because all of this is coming at a cost, and it's coming to a cost for ourselves. And consequently, our employers, or if you're self-employed, to yourself, etc., right? And we strive so much about talking about user experience and making the lives of our users simpler. and making it easier for our users to not have to learn interfaces or read documentation to understand how things are. And yet, so we strive for that simplicity, but we don't seem to do that simplicity for ourselves. Right? For us, it's like, oh, well, this framework solves all the problem except this 10%, so I'm going to make it a little bit more complex, and everyone can learn my new framework, which is solving all of the problems that they don't have, but anyway, they're going to learn that. So we really, really, really need to try and strive for simplicity. Right? It's okay to solve complex problems, but try and do it in a simple way. And I'll finish with this very, very famous quote, which I'm sure you've all heard before, right? It says, you don't want simplicity because you can't handle simplicity. You need the complexity. You want the complexity. We use acronyms like YACNI, KISS, and DRY. We use these as the backbone of a life spent designing with simplicity in mind. You use it as a punchline. I'm sure you've watched that movie. Yes. Okay, thank you. And that means that you're free to go to your continuous eating thing earlier.